Okay. Hello, everyone. Thank you so much for joining us for today's webinar. We are thrilled to have you all here. And this is a very exciting webinar as it is our last one before the conference itself. So before we get started, let's start with our BECC hold music, and then we'll get right back to you.
Well, we got a changing world. We need changing institutions. To scale up climate solutions. We're waiting on this webinar that has been arranged to learn how our behavior can be changed. We gotta change our minds if we're going to change hearts. But right now we're just waiting for this webinar to start.
Okay, thank you again for coming today. We're just about to start today's webinar, but before I do, I'd love for everybody to just pop into the chat. What's one smart technology that you're familiar with, that you've experienced? And let us know, has that been a good experience, a bad experience? Do you like it? Do you not? What do you not like about it? So what's one smart technology that you've experienced in your life that you want to highlight for us? And while you're putting that into the chat, I'm going to go ahead and start today's session. And let me just see actually what's coming into the chat so far. Programmable thermostats, Suzanne Coco. Smart bulbs, yeah. Smart thermostats, Ian Shovelin. Now, tell me more than just what the technology is. Has it been good, bad? Any, what do you like or not like about it? Smart thermostats, smart bulbs are classics. Yes, of course. Kalar, smart lighting, great experience. Carla, Bluetooth lights. Teresa, she can't turn on her TV because it's too smart. Ian, being able to control the temperatures from afar is really handy. Good, that is a nice advantage. Susan mentions the impact on bills. Ted says that the Nest thermostat's not a very intuitive program, is actually being frustrating with it, which I imagine is some people's experiences. All right, so thanks so much for chiming in on the chat. I see some more chats coming in, and that's great. Let's get started with today's webinar. My name is Reuven Sussman. I direct the Behavior and Human Dimensions program at the American Council for an Energy Efficient Economy, and I'm a co-chair of the BECC conference, Behavior, Energy, and Climate Change. I run the webinar, but I am not the feature speaker today. We'll get to those people very shortly. And I just want to mention the conference is coming up so soon. Just a couple of weeks, and this year's theme is engaging all voices. We're so excited about the conference this year. We have over 40 sessions, over 115 speakers and presenters, panel discussions. We got your interactive workshop solution sessions, and the first ever Shark Tank. That's the TV show. We're not going to have an actual tank of sharks. The film festival, the yoga, networking dinners, BECC bunnies, everything you could want in a conference is going to be fantastic. We have an online version, an in-person one. And I just wanted to highlight our keynote speakers that are coming to the conference because this is our last webinar before the conference. The virtual keynote is Dr. Linda Stegg, well-known professor of environmental psychology at the University of Groningen. And then the in-person opening, we're very lucky to be able to have Deborah Gorman, the president and CEO of the Green Lining Institute, doing some fantastic work regarding equity, environmental justice, and energy. And then, of course, the closing keynote will be Dr. Tony Reams, the Deputy Director for Energy Justice at the U.S. Department of Energy, responsible for the Justice 40 initiative and a lot of other really exciting stuff. That's our keynotes, which you might find interesting, and I highly recommend you check out. I also want to highlight that this year's conference is going to be taking place in two different formats. The virtual opening day, 100% virtual on November 9th, and then the in-person conference, your traditional BECC conference, everything you hoped and dreamed of that would come back after 2 years of being virtual, is back at the Capitol Hilton in Washington, D.C. Now we have, if you register for the in-person conference, you are automatically granted the virtual opening day because it's part of the conference. But if you want, you can't come to the full conference, that's okay too. You can register just for virtual opening day as a standalone option. Visit becconference.org for details. Of course, I want to thank the sponsors before we get started. These are absolutely critical both to the conference and to the webinar that you're viewing right now. Now, to this list, I also want to note that we've added Nature Energy, supporting the BECC Fellows Program, and NREL, National Renewable Energy Lab, which is supporting one of our solution sessions. So thank you to our sponsors. Now, some logistics before we get started. Please remain muted during your presentations. Now, if you want to turn on your camera, that's fantastic. We love seeing everybody here. BECC is a very inclusive community, and we love to see everybody and be able to chat with you directly if you want to, but you don't have to turn on your camera. Just remain muted. Use the chat for questions and discussions throughout the webinar. I'll be watching the chat for your questions, and you can also directly chat anybody else in the webinar as well if you like, because we're using Zoom meeting. And we'll have time for questions after all the presentations. So you can type your questions into the chat throughout the presentation. I'll keep note of them, and then we'll ask them to our experts at the end. So that's it for my intro. I'm very excited to now turn it over to our two speakers for today. They'll be discussing equitable digitalization of residential energy technologies. Today we have Carlos Martin, Director of Remodeling Futures Program at Harvard Joint Center for Housing Studies, as well as being a Rubenstein Fellow at the Brookings Institution. And we have Therese Preffer, Associate Director of the California Institute for Energy and the Environment, and of course, our beloved BECC co-chair. So I'm going to turn it over to Carlos first. Thank you, Carlos, for joining us on your travels. I understand you're joining from an airport, so thank you very much for being here.
I am. Thank you so much, Ruben. And hopefully you all can hear me. All right. So if at any point I lose video, please forgive me. It's a great pleasure to join you. And let me just say that's the best intro audio clip I've heard in a long time to any webinar. So I'm assuming that, Ruben, you had something to do with that music. So I quite enjoyed that. Thank you for that. So let me give a little bit of a series of caveats around the paper that we're presenting at the discussion that Dr. Pepper and I will be having. And so this started as a conversation we had about almost a year ago, or half a year ago, I should say, at the Harvard University's Joint Center for Housing Studies Digitalization Symposium. And that symposium was really focused on all manners of digitalization, from housing finance to housing purchase, et cetera. And the conversations about the housing quality where we had this conversation. And the real focus there was really reminding people that digitalization in the housing, energy digitalization in particular, started with energy. It was a very important sort of way of thinking about how to send information signals and how to have consumer occupant responses. So it's a very important history in the bigger conversation about digitalization. But let me also take a moment to remind us all why we're doing this. And so I'm going to start sharing my screen. Hopefully you all can see. Let me get a thumbs up. All right.
Looking good, looking good.
Crowd are not going to be surprised by why we focus on every manner of way in which we can improve energy efficiency, energy conservation, and long-term electrification. And that is that we have a climate crisis on this planet.
Carlos, I'm just going to jump in here and just suggest that maybe you turn off your video because there is a little bit of a network lag. Sorry to everybody, but I think this might help things go a little better.
All right. Hopefully that's working better. And if not, we'll figure out another strategy. Again, I apologize and to my travels. So I mentioned the fact that we have a climate crisis. We know that 20% of US greenhouse gas emissions come just from our homes. And that quantity is so large that it's the equivalent of the 6th largest greenhouse gas emitter on the planet. So we need to fix how we're dealing with our housing, and that includes all range of interventions, including energy efficiency and the ability of digitalization to help us control our energy. So that sort of the challenge has been stubborn despite all the conservation and efficiency efforts we've had in new homes, all the retrofits of older homes and replacement of older appliances that started in the 1970s. And that same conservation and efficiency movement seeded energy digitalization. So it's been a long time coming. We've had digitalization efforts since the 1970s, and certainly Dr. Pepper will talk a little bit more about that history. But I want to make sure that we understand that this is built up a technological momentum, and there's always, room to question when we have these kind of technological momentums, to look back and look at who's really benefiting from these interventions and from the variety of interventions. Ultimately, if climate mitigation is our goal, and decarbonizing American homes is our strategy, we have to ask, why is energy digitalization the chosen strategy, and who benefits from it? So I want to remind folks again that there is a clear challenge that we have when it comes to various populations in the United States, starting with it by income level. So if we look just at the energy cost burdens for lower income households compared to higher income households, we see a clear difference, almost double the amount of housing budget that goes just to energy costs. We have to remind ourselves that energy rates are not prorated based on the ability to pay. So your kilowatt hour, of course, there are time constraints around that, but certainly the real challenge is making sure that lower income households have the ability to afford their energy bills as much as all of the other bills that they have in front of them. There's a clear concern about energy insecurity in all of these populations. So I'm referencing the 2020 RECs, and as we know, the energy insecurity questions that came out of RECs were a bit dated when we compare that to the household poll survey, for example, that shows that energy insecurity are about, in some cases, up to 6 percentage points for some of these questions around energy security, higher than what we saw at the point of REC. So this is the real issue. We know that lower income households are more likely to be energy insecure. So the question is, and particularly those who are renters, so the question is, how do we provide interventions that ensure that this population is not overly burdened and not challenged as we decarbonize our homes? So let me take a little quick step back to talk a little bit about the policy, the revolution of home energy. I talked about the energy conservation R&D movement that began in the 1970s, but this of course led to the electronics revolution and the move to all digital controls in the 1980s for a variety of appliances. Combine that with the residential efficiency and design of construction and maintenance that began in the 70s, but really was, if I can say the word, perfected in the 1990s with programs like Energy Star, with Building America, et cetera. And then these, of course, led to an expansion of residential renewable energy that required two-way communications in the 2000s, thanks in large part to the American Recovery Act. Broadband availability in the 2010s and leading to the wireless signals and transmitters, and the home automation movement that has really peaked in the 2020s with virtual assistant technologies, like some of the ones that people were putting up on the chat, the Alexa, Echo, Apple, Siri, etc. Obviously, the holy grail is mass electrification, grid interactive efficient buildings, which we know that DOE has an active agenda in. So it's been a long time in coming. So when I talk about technological momentum, I'm very conscious of all of the efforts and R&D efforts to perfect these technologies. So the question really becomes, how well are they implemented, and who gets to implement and benefit from them? So I do a sort of rough cut of the technologies, those that are inside the home and those that are outside the home. Obviously, the smart meter is the locus of home residential home energy digitalization. So being able to communicate with your utility and the grid is absolutely critical. But we obviously have a lot of products that are inside the home, the programmable thermostats, the smart appliances, etc. I found it interesting that in the chat, nobody put their smart meter as their designated technology of choice, likely because they don't own it. They don't actually control it. They have very little to do with the actual smart meter, right? So it's important to think about who controls where the data is coming from and where the data is being displayed and who acts on that data. So inside the home, obviously, we have in-home energy displays that Dr. Pepper will speak certainly a lot more about, and the behaviors associated with that. But outside the home, who has access to these technologies, who has access to the information that is produced from them, including third-party energy services as well as the utilities themselves. And there's a bigger policy context that's been supporting a lot of this. And that really ranges from remembering that utilities' primary interest is to manage energy for grid stability, to ensure consumer efficiency, and in many cases, just to ensure utility profit. In the making, this has been in the making for a while. We have a parallel history about enabling technologies that have occurred at the national level that go back to the National Energy Policy Act in 1992, which allowed for competitive electricity generation, and the Energy Policy Act signed in 2005 that allowed for utility regulation by FERC, by FERC rather than SEC. So there's a contemporary debate over how to decarbonize the energy grid. As we know, that was in the recent Inflation Reduction Act. So the question is about what kind of enabling technology, what kind of enabling policies allow for this sort of come to light. On the regulating side, we know that a lot of state energy commissions or public utility commissions also have been debating a lot of these issues for quite some time. And in some cases, just allowing meters physically, knowing that large utilities began installing smart meters, for example, 2 decades ago after states started permitting them. And with those allowances for physical installation of smart meters, allowing consumer opt-outs. And that obviously the challenge if you're trying to manage a whole grid, electric grid, as well as trying to help individuals with their own energy bills, allowing consumer opt-outs is a bit of a challenge. Second is demand response management. So a lot of state utilities have been, state utility commissions and energy commissions have been very particular about allowing rate variability depending on hour of use, et cetera, which smart meters essentially enable. A third issue is, of course, net metering for distributed energy. If in places, for example, like California, that are permitting extensive distributed energy at the residential level, how that is not only financed, who owns who controls the rates of that two-way communication, but also then who owns the information that allows that to actually occur. And then fourth, and probably most significantly, is the issue of privacy and data sharing. This is where there has been a lot of consumer debate regarding how much information is provided, how much consumers are aware of the kind of information that is provided on their about their energy use, and who receives that information. In most cases, though, state regulators have been generally as supportive of energy digitalization as the national government. One of the questions, of course, that we have is whether we actually will see benefits from digitalization. We've all seen, especially I'm sure everybody who's listening on this webinar knows of the studies that project how much we actually can save from any range of these energy digitalization technologies that we're talking about. So of course, there's one study that predicts energy savings on the order of 88 gigawatts if there's mass digitalization, which is the equivalent of 25 million photovoltaic panels. So there's great opportunity there. Pilots, though, suggest about a 4 to 12% individual home benefit, that's in savings to an individual household, and an overall 0.4 to 6% reduction in the aggregate of residential energy use. So it's a modest. Pilots are usually, though, of course, of one or small combination of technologies and have very clear selection biases, but they do contribute to our understanding of unique energy behavior. Among the most rigorous studies, though, there obviously are contradictions to these demonstrations. We know the experimental study known as Smart Tech Dumb Humans that was published a year and a half ago. Actually almost a year ago, that found that smart thermostats installed for free had no statistically or economically significant effect on energy use. In fact, and found that user behavior dampens savings and explains the discrepancy between the engineering models that we see that are predicting these estimates in front of us on the slide and actual field observations. So we know that digitalization works, but sometimes, and sometimes only modestly, and probably only in conjunction with other activities, other energy interventions that digitalization enables, such as efficiency improvements or mandatory demand shifting. So we also know that actual diffusion rates are very variable when it comes to some of the technologies that we've been talking about. That's why I've joked that nobody actually mentioned smart meters as their technology of choice when we were doing the chat, even though that is the most profuse of all the technologies that we've seen, at the rate of 65% of homes having digital smart meters since the technology was patented 50 years ago currently. Within individual inside the home kind of technology, we know that the adoption rates are relatively modest. We're talking about 12% to 21% in most US households, with HVAC controls probably being the most commonly reported ones. 17% of homes, for example, having programmable thermostats. So knowing that there actually is a major impetus for, particularly at the smart meter locus, most households, though, are unaware whether of their smart meter. So you make sure that we saw 65% of homes actually have digital smart meters, according to utilities. But over 42% of households don't know whether their electric meter is smart. So there's a lot of unawareness about sort of how their energy information is produced and who manages it. In some cases, I'm quoting from Dr. Diana Hernandez now in her upcoming book on energy burden, when she said she interviewed a respondent who had didn't know that they had gotten a smart meter, but did know that at one point and I'm going to quote here, the respondent said, I probably get a bill that's 169 or 159 or something like that. It wasn't ever the $200 that I'm seeing now. I don't know how they do it. And what she didn't know was that at that point, that transition point, she had transitioned to a smart meter that had demand response management rate rating that had changed. So who is benefiting from these technologies is the core question. We know that controls are not evenly distributed and across income population. If we look just from the latest 2020 REX data, we know that 42% of homes with incomes less than 60,000. So the way you see it there, the income levels are broken up by very small groups at the lower income level. But if you aggregate all of the ones at the middle and to the left, so 60K and less, about 42 of those homes have non-programmable thermostats. So there is a wide proportion of people who just don't have access to more sophisticated in-house technologies. And that's the same in air conditioning controls as well. Knowing that if we look at the other side of the above 60,000, okay, that population is about 4 times more likely to have smart thermostats. So where does that leave us? One of the questions that we are posing, in addition to this issue of access, is whether different folks at different income levels, as well as different kinds of cultural groups and other protected classes, actually treat these technologies differently. This is where I think we're going to have a lot of interesting conversation with Dr. Pepper, because I joke that I tend to be a pessimist. I see the glass half empty, and I note that the majorities at all income levels are actually overriding their temperature, if they have the thermostat, overriding it in some way, like setting the temperature at the thermostat at one temperature, leaving it there most of the time, or manually adjusting the temperature, or turning the equipment on and off. In fact, one of our co-respondent to our discussion at Harvard noted that, and this is a full tenured professor at Harvard University, who said, "Oh, I always just manually adjust my thermostat. I didn't know there was something different that I could do." She's not in the business, folks. She's an urban planner, but I thought that was an interesting case, that somebody with that level of sophistication, and one would assume educational capacity, was unaware of how to manage their systems. So how do we fix this? How do we deal with this? My concern, of course, is that when we're talking about low-income houses in particular, we have to think about digitalization as one strategy among many. If digitalization is not immediately accessible to a lot of these households, why aren't we pushing for greater weatherization, the expansion of the weatherization program, other retrofit programs to actually improve efficiency, that improve electrification rates and include distributed renewables, in addition to, in some cases, before digitalization, to ensure that those communities aren't disproportionately affected by the changing cost structures of digitalization. we have to make sure that we're increasing assistance in proportion to these alternative rate pricing and demand response systems. Remember that if this transition, in fact, when I was writing the original paper, I just Googled any news stories about digitalization, and there was Xcel Energy in Colorado had just created a demand response management system. So a reporter from the local newspaper in Denver went out and started interviewing people, and a woman said, "Well, I can't do that because I can't control how often I have to wash my baby's diapers. So I will suffer as a household because of these new cost structures." So making sure that we're very conscious of user behaviors and making sure that for particularly low-income households, there's enough assistance, enough awareness building for those communities than is currently available. I'll just leave it at that. We talked a little bit more about privacy and data sharing. Just for the purpose of time, I do want to note that there are a lot of great nonprofit groups out there that are trying to get access to people's information. I'm always willing and happy to cite Elevate Energy, our good friends at Elevate Energy, who have been advocates for ensuring that nonprofit organizations and those who offer energy assistance are actually among those that are allowed to get access to this data so that they can provide a useful and needed service to their community. But in either case, I will happily end my slide right now because I want to get into the conversation about who's more pessimistic versus who's more optimistic with Dr. Pfeffer. So I will pass it over to her.
Great. Thank you, Dr. Carlos Martin. I'm delighted to be here today and to participate in this. I'm assuming you can see my screen.
Yep, looks good.
Okay, great. Thank you. Yeah, delighted to be here today. I greatly admire Dr. Carlos Martin's work. His paper that he presented back in March at the Digitalization of Homes was, I think, just a fantastic paper. I can't wait until it's published. I've never seen such a comprehensive paper that covered policy, behavior, and all of these technology, all of these different issues. So I think it's fantastic. I'm going to focus on one smart technology, which has both energy and equity impacts, which is thermostats, which I've been studying for more than 15 years now. Let's see, how do I advance? There we go. Okay, so since this is Beck, I'm going to start with a story. Over 20 years ago, I volunteered with an organization called Rebuilding Together. This is a volunteer organization that brings people together for a day in the spring, usually, and you go to houses in seniors and underserved communities and fix up the houses. It might be painting, it might be clearing out a house or outside work, building a staircase that's falling apart. I was part of the energy team. And so instead of just focusing on one house, I went to 5 different houses. And we installed, 20 years ago, so compact fluorescent lights, more efficient than incandescent. And caulking, we were all the plumbing that allows that goes through the walls and allows infiltration. We were trying to plug up those holes. I don't know if you've seen these. These are little insulation strips that you put behind your outlet for those exterior walls, again, to block infiltration. And one piece in our arsenal was a programmable thermostat. And so we went to each house. The first house, the person we installed the thermostat, they were fine with it, no problem. We went to the second house and installed the second thermostat. We got a call back when we were on our lunch. Please come back and pick up this thermostat and reinstall my old thermostat. I can't use it. I can't figure it out. I don't know how to program it. And we were able to install one more, but it was a senior who had a grandson living with her. And so, oh, it's okay, he'll be able to deal with it. And so this was my first experience with looking at a technology that can save energy, but people can't use it. So you might want to know, well, why do we care? Why is that a problem? So I want to talk about what happened in California in early September of this year. This is a chart from the California Independent Service Operator, or CAISO, which manages the flow of high voltage, long distance power lines for the grid, serving 80% of California and a portion of Nevada. And this nonprofit public benefit corporation forecasts electrical demand and then dispatches the lowest cost generator to meet this demand. So about 7 weeks ago, electricity demand in California hit a record peak. So the way you read this graph is on the x-axis is the time over the course of this one day, 24 hours. And on the y-axis is the demand, the electricity load in megawatts, right? So it shows the demand in green and then the net demand in purple. And this has to do with the solar coming on, as you can see there in the morning, and offsetting quite a bit of that load. But the problem was the peak here in the afternoon. And we were all very worried about rolling blackouts. We thought that the power was going to go out. This was a record peak demand of 52 gigawatts. The last time we saw anything close to this was 2006 with 50 gigawatts. So this was a really big deal. People were pretty concerned about this, and we were able to, most of the lights stayed on. It actually worked out really well because, I should say most of this load is air conditioning. In California, the peak demand is driven by both residential and commercial air conditioner. It was 114 degrees where I live. So this is a major problem. Also, because this is BECC, I will point out that CAISO sent a text to 27 million customers in areas that have air conditioning and asked people to reduce, and it worked. It was 2.5 gigawatts of savings just through behavioral intervention. So here are some other cool facts. I just mentioned air conditioning drives peak energy use, but it's become necessary as climate change causes more extreme heat events that are increasing both in intensity and frequency. The US uses a lot of electricity for cooling. A lot of folks have air conditioning, and of course, air conditioners themselves have refrigerants that are a big cause of global warming. But as Carlos mentioned, there's also an equity issue. Households that have low income tend to have older, leakier houses, less insulation, older equipment. More of them rely on window AC units. There are very few smart thermostats that work with these AC units. And many suffer from medical issues where you can't offset the temperature to save energy because of those issues. So the graphic on the right shows for households that are receiving federal rental assistance and the number that are seniors or disabled or have children. So let's talk about smart thermostats. I define smart as connected or networked and having some advanced functions, usually because of some computational capability. So there's a relatively recent study that reviews thermostats and weatherization programs around the US. And I don't think anyone is super surprised by the findings here. You need broadband, as Carlos was mentioning. Clients need to demonstrate an interest and be technologically savvy and have access to troubleshooting. And a lot of one of these older homes, older equipment, there's technical issues that cause problems with installation of these smart devices. And if you're going to save energy, you need actually to, one of the ways you save energy is to leave the home, and then you're setting back the temperature so your heating or cooling systems don't come on. But people of low income tend to spend more time at home, whether they're seniors or have children or what have you. There's the report there. So moving on, let's see, there we go. So one of the things I wanted to ask is just to talk about thermal comfort and just ask you all, what temperatures are you comfortable at? And you can go ahead and type it in the chat if you like. So this was a study, I'll give you the results here in a second. This is a study from a researcher in Davis who asked people, what are your low tolerable temperatures? Well, what's low temperature that's ideal? And then the same thing, what's a high ideal temperature and high tolerable? And so what you see here is a huge variation, right? You have some people who are comfortable at low temperature, 50 degrees, and other people's low is tolerable is 78 degrees, right? So a huge variability. And part of this is, it could be seasonally, it could be time of day, it could be what clothes you're wearing or whether you just came in from a run or what have you. But I just wanted to make the point that temperatures, thermal comfort is variable. It's not just a very narrow temperature band, but it's actually quite variable. So in going, looking at how people are using the thermostat, so this is a little similar to what Carlos was showing. You see, so on the graphic on the left there, you're seeing temperature setting behavior for heating across LIH's low-income home, then middle-income, and then high-income homes. And you see more of a tendency to set it and leave it, and a lot fewer households using the automatic adjustments. When you look on the right, this is the difference between the heating set point for rented homes versus homeowner-based households. And you can see the difference between the temperatures set for home and away. Obviously, a higher temperature setting for heating is going to use more energy. This could be reflective of these facts that people are home more often, or are, like I said, have health issues or are senior. And then on the cooling side, you see something pretty similar in terms of setting behavior, fewer people using automatic adjustments. And if you see on the left there, nearly 50% of the low-income households don't even have air conditioning, right? And so that is an equity issue. And then, yeah, on the right there, you see, again, higher temperatures for the low-income households. This is using, lower temperatures for the low-income households, which is using more energy for those programmable thermostats anyway. And so I wanted to walk through the thermostat designs have really been impacted by digitization and digitalization over the years. So I wanted to kind of go through thermostat design over the past 70 years. This is the Honeywell round from 1954. Looks like a knob, easy to figure out. You're supposed to turn it, very clear on-off settings. And then right after the oil embargo, we got the Honeywell Chromatherm. So this is a very early programmable thermostat that you could set different temperatures for nighttime. And then we have the Emerson. This is a thermostat that's really typical of the design of programmable thermostats in the 80s and 90s, with a very small LED screen, up and down arrows, buttons, and so forth. And then along came Nest in 2010, not the first networked thermostat, but certainly a game changer in the use of color and aesthetic. And of course, for learning, being able to learn people's schedules so you're not you're not tasked with having to do that manually. And then other thermostats, here's a Lennox. This is available at Costco. And you see, again, the color, the touchscreen. You can see that we've gone from an analog way of visualizing temperature to digital and then back to analog again. These are, again, big, colorful touchscreens. You can see outside temperature. Some of these you can play music and you can display photos and other things. So it's much more broad than where you saw thermostats 70 years ago. So one of the things we looked at is in terms of how are these saving energy that Carlos mentioned. You may know that the Energy Star for programmable thermostats, that label sunset in 2009 because there was no evidence that these devices saved energy. And then this is a more recent paper indicating that, again, just following what Carlos was saying, the smart thermostats don't necessarily save energy. Here's a graph that just shows that these set points are easily overridden. So I started getting very interested in usability. And one of the first things I learned about usability is to not call it user-friendly. It's not a term of art in that world. I don't want the device necessarily to be friendly. I want to be able to use it. And so this is, I'm using usability expert Jakob Nielsen's excellent guide here to describe the role of usability in acceptance of a technology or adoption of a technology. And this is from 1993, but I think it's still very relevant. So two elements of acceptability or adoption of a technology are social acceptability. Are other people using it? Is it culturally acceptable? And practical acceptability, which includes things like cost, compatibility with your equipment, reliability, but also a term called usefulness. And he defines usefulness as a combination of utility. What does it do for me? How do I need it? What is it accomplishing for me? and usability. And usability here reflects, is it easy to learn? Is it efficient to use? Is it easy to remember? Does it produce few errors, and is it subjectively pleasing? So I was involved with a research project a number of years ago where we took 5 thermostats, a web browser, a touchscreen thermostat, a smart thermostat, a button thermostat that had all button controls, and then a hybrid, which had both a touchscreen and also had buttons. We had 31 subjects, each of them reviewed 2 thermostats, and we had 7 tasks that ranged from, was supposed to be an easy task, all the way to something more complex. So first, just set it to heat mode, set the time of day, what's the current temperature, identify the target temperature or set point, identify a future target temperature, and then program it in some way, set the vacation mode, away mode, or so forth. So our goal here was to look at these. We were identifying a number of different features. We were looking at how much time does it take to complete the task, how many steps, or what is the path length is what we called it, and then the success rate. And our goal was to try to come up with a single number that would correlate with usability. So this is the result of the first task, which is just set it to heat. And so you see across the bottom there are the 5 different thermostats: the web, touchscreen, smart, button, and hybrid. And then here the plus sign shows this is, it took them about 3 seconds to complete the task. That's what the plus means. And then here's someone who gave up after, what is that, close to 2 minutes, that they couldn't figure out how to do this. Right, you have someone up there on the hybrid that took 10 minutes to give up. Got to admire that. And then we looked at the number of steps. How many button pushes? How many steps did you have to do to complete this task? And it ranged from 1 to 4 for this particular task. And then we looked at the success rate. So 100% of the people using the web interface with a single path length were able to accomplish this. But look at over here. The hybrid thermostat, only less than 50% of the people could figure out how to turn the thing on to heat. This is a huge problem. So one of the things we did was to look at different usability heuristics out there in the computer science world, in the embedded device world, in ergonomics. And we tried to come up with different guides or these heuristics or rules. And we wanted to see if there was a correlation between these rules and what the usability metric was. And we did come up with some. This is the list of the heuristics that seem to make the most, that seem to have the strongest correlation. And so more recently, I applied these heuristics to a set of thermostats. And what you see here is a color coding. Dark green means the thermostat supported the heuristic very well. Gray barely supports, and orange means it does not, that thermostat does not support that heuristic. And we think there's a correlation between poor supporting of a heuristic and poor usability. And so this was presented at Summer Study just a few months ago. It needs to be validated, but it gives us a sense of how we might look at these different devices and determine how usable they are. One fun project I got to do a few years ago is to design a thermostat for a house that doesn't have the internet. So for a house that doesn't have Wi-Fi, which you often see in lower income homes. And the goal with this project is to create a very simple wall interface with limited functions. And then there would be a Bluetooth connection to a smartphone for a richer interface, such as programming and tips and things like that. So with all that we had learned about for usability, we had a very prominent on-off button. That's a real great way to reduce your energy consumption, is if you can turn off systems. A timer function. So if you just want the cooling on for 15 minutes because you just come in after a run or something like that, you can do that. That's what's showing there. So 15, 30, 45 or 60 minutes. And then an analog display of temperature. And the idea behind this is, again, because thermal comfort is so variable, the idea, just like in your car, if the knob is facing kind of straight up, maybe you're slightly cool or you're slightly warm, but that's kind of your comfort zone. And then as the dial goes more to the right or to the left, that's where you need more heat or you need more cool. So that was the idea behind having that analog display. And one of the things we realized too is that we wanted to design for multiple users and contexts. So we had 3 main modes. We had a schedule mode, and you can imagine that some people like a regular schedule, or maybe in the winter or the summer season, that makes sense to have a regular schedule. Smart mode, some people like the automation there, just set it and forget it, don't have to worry about it. It's automatically switching between cooling and heating. And then some people are fiddlers. They like to control on and off, and maybe this makes more sense in the swing season where you have a hot day one day and a cool day the next, and you just need to fiddle with it directly and manually and not rely on the smarts or a schedule. All 3 of these modes need reinforcement through design, through good usability, through wizards, through training. And I think I mentioned it could be the same person over different seasons, or it could be just different personalities and values. So with that, I will end. I do think thermostats can help save energy and reduce peak loads, reduce emissions, and keep the lights on. I think we have to recognize that thermal comfort varies with season, outdoor temperature, activities, age, health. And I do think usability is vital to technology adoption and equity. We have ways of evaluating this. I think we should use them. Certainly training people how to use these thermostats is going to help, and motivation through pricing is effective. I think we have to recognize that one size does not fit all. So thank you. I appreciate your time.
Thanks, Therese. I'm going to invite both Therese and Carlos now to turn on their webcams and unmute. And now we're going to take some audience questions. These are interesting talks, and I sincerely appreciate you both bringing them both to us. There's been some chatter in the chat, which I guess is kind of a redundant way of saying that. That's where you put the chatter. So just a few comments first for Carlos. Ted Cousins, or rather Laura Supple, noted that the anecdote from Dr. Hernandez's book highlights an important aspect of this question of who actually benefits, not only who buys and installs the technology, but who has agency and information to use and employ and manage the capabilities of these different technology systems to suit their needs. Do you have any comment or response to that?
No, that's exactly right. I mean, that's the questions that we have to be posing with any new technology, particularly those that are meant to provide a broader societal goal. So I think I definitely appreciate that comment. I think the challenge is then how much of who's in the driver's seat about deciding which technologies are included in your home and how much are they familiar with them. So it's one thing for a utility to put in a smart meter, which is now 65% of homes now actually higher than that, because that was already we're waiting for the next data to be released. But the real challenge is how much are people actually aware of that, and what do they benefit from that. So I think a lot of it is just education, and the hard challenge with a lot of this is that so much of the education is very sort of one-way, passive, and there isn't, for a lot of communities, they need a lot more case management, a lot more deeper understanding about what the decisions that are being made, so that if they can understand why they're getting charged different rates for different times of day, right? Once that technology, because they'll blame the technology instead of the process in which this technology was rolled out. I like to fancy myself a historian of technology, and I always say, quote Melvin Kranzberg, and I say, technology is neither positive, nor is it negative, nor is it neutral. It's all about how technology is used to empower people, and particularly vulnerable people who don't have power historically.
Thanks, Carlos. Now, in line of our theme for this year's BECC, which is engaging all voices, Laura Supple and Amber Stewart have 2 comments about one type of population, which is elderly, older populations, which I think are kind of both together. Therese, I'm going to direct this towards you. Laura asks, how are smart thermostats considering or not considering accessibility for those with different abilities, or visual, auditory impairment, for instance, other form of cognitive disabilities? And Amber also similarly asks, has there been any research into how smart technologies can help people age in place? I feel like these two questions are somewhat related. Therese, do you want to take that?
Sure. So thermostats, there are thermostats that have speakers that you can directly talk to them. And so that's a way of saying, please raise the temperature. And now, of course, with Alexa and Google Home and all of those smart speaker technologies, there's another way of accessing that. You could argue, like, I don't know that my mom would ever use an Alexa. I think she would find it very crazy to say, turn up the temperature like that. That doesn't feel natural. So I'm not sure how else to deal with that. I do think that I know when there's a whole controversy, I think, between, I like the haptic motion of the Honeywell round and the Nest. It looks like a knob. You want to twist it. I've heard that. I've heard two different things. One is that mechanically, that's harder and more expensive to do. And I've also heard that twisting mechanism, that's why we don't have doorknobs anymore, right? We have levers to get in and out of homes and businesses, because it's easier to push down than it is that twisting motion. And so I do think push buttons might be easier for some people. I don't think they're as haptic. I hate push buttons myself. So I think it's still an open question, honestly. I don't think that I've seen some designs try to get at this, but I think it's still an area of work. I want to point to Carlos Martin to ask the question, or to answer the question about aging in place, because he has a colleague at the Joint Center of Housing in Harvard who's doing exactly that.
That's exactly what I was going to say. Let me just the overall comment. I think we're talking about two different challenges. One is a physiological one, right? The ability to actually understand, to see and manage the display, which is a problem not just for elderly people, but for physically challenged people, particularly those with visual or hearing impairment. So Dr. Pepper was mentioning some of those technologies that are trying to circumvent that. But the other challenge is the savviness, like the I don't want to use the word Luddite, but it's essentially the inability or desire not to use a technological system for something that they feel they can control otherwise. And I think that's going to be the more challenging one, particularly for elderly populations, but particularly for people who have distrusted technological interventions in the past, which are a lot of low-income people, a lot of people in underperforming housing. So I think that's a bigger issue. But so I put the link for the digitalization symposium in the slide. And so just for the purposes of brevity, look at the so the aging in place and home automation presentation occurred at the same time as the energy one, and Dr. Pepper was also responding to that one, so I definitely encourage you to look at that one. But there are really interesting experiments that are going on, paid by healthcare providers and by medical providers, to use automation techniques for health notification. We all know the sort of the joke of, sorry for the noise. We all know the joke about, I've fallen and I can't get up, which isn't really a joke. It's a reality in most people's lives, and in particular for those of us who are hitting that age. So I definitely encourage you to read that paper.
Thanks, Carlos. There's a couple of questions. I guess this is for Therese. Regarding the slide in which you showed low income, medium income, and high income households, and the frequency of setting and forgetting sort of kind of behavior versus frequent, changing of the thermostat. And Laura asks, is it only households with smart thermostats, or all households, or is it all households regardless of technologies that you're measuring in that graph? But more importantly, I was wondering, or as importantly, I would say, is like, why is there that difference? What is it why are higher income households more likely to use automation, set it, forget it, whereas low income households not likely to do that? And, Ian, for example, acknowledges that reliable Wi-Fi is a huge barrier for low income. What else should we know about?
Well, I do think familiarity with technology and trust in technology. There was an example of a thermostat demonstration, and it was in Texas, I believe, where they installed these smart thermostats in low-income housing. And after a few months, they had to take them out because someone told someone else that there was a camera in there. And all these people were very concerned that they were being observed. And for some people, if you're undocumented, that is a huge fear that's very real. So they had to rip out 100 smart thermostats because of this. So I think it's a couple of things. I think it's a familiarity with technology. I think if you are, if you leave from work every day at regular times and come back, you're more likely to have an automatic type schedule that can do that. If you're at home all the time, you're not leaving. Why would you need any sort of automation for that? I think there's a real fear about learning mechanisms and data privacy that Dr. Martin was mentioning, right? I think all of those are concerns. And you have to consider too that most smart thermostats are associated with air conditioning. And so it's the newer houses that have air conditioning that are going to have the more advanced thermostats. It's those houses that are old and only have heating that are going to have the thermostat that originally came with it 50, 70 years ago, right? So there's a number of different trends there that I think account for that difference.
That's exactly right. I can agree with you more. There are a lot of confounding factors in this. I mean, part of it is access issues, right? That higher income people have the technologies in their homes. And so the graphs that you saw from Dr. Pepper as well as mine factor out people who don't have the technology, right? So, and just measure their behavior, assuming that they have, with knowing that they have the technology. So that's a challenge, right? Or we note that in the charts. So you can see that when you get the slide. I think another issue is that people tend to know there's sort of a cadre of your peers. So it's not that it's not peer pressure that you want to get a smart thermostat, but people become aware of it because they go to people's houses that have the same technology, right? So it's this question of what segments of the population are occupying what housing, which is exactly what Dr. Pepper was talking about. I think a lot of it is this issue of trust with the technologies. And so Dr. Pepper mentioned there actually are documented cases of, for example, Immigration and Customs Enforcement using utility data from smart meters to raid households and deport populations. And the paper that you'll see from on the website, there's links to the newspaper coverage of those cases. There's also significant cases of law enforcement, criminal enforcement using utility data to identify meth labs, to identify pot farms, et cetera. So there are a lot of there's a lot of concern about the use of data. So even notwithstanding those sort of criminal, ulterior kinds of information sharing, there's a general lack of trust that people have with somebody else managing their energy decisions. So I recall in one study, and it's noted in the paper, about 40 to 49% of the households were willing to adjust their timing of use. They're willing to have a smart meter and have demand management rates, but only 25 of them were willing to allow the utility to do that. Essentially, they didn't want somebody telling their appliances and systems when they should be on and off. They wanted to be the one that decided that. So there's a lack of confidence. I think that is a real concern.
Yeah, that is so interesting. So some of these concerns are founded. In 1 minute, could you each sort of sum up your stance on smart technologies? Are they good? Are they bad? What needs to change? Could you do it in a minute? Oh, let's whoever wants to go first, go first.
I'll go first now that the family that was sitting next to me the whole time is gone. So I can talk, and you can hopefully hear me a little better. I would say it's neutral. The reality is that smart appliances, smart meters can be a tool, but they are only one tool, particularly for low-income households that live in substandard housing. We need to think about the kit of energy efficiency, direct energy efficiency, including insulation, appliance upgrades, et cetera, that can help those communities as much as then being able to manage their energy information.
And I'd say I'm cautiously optimistic. I do think that we need to look at the big picture, and we need to look at policy and technology and people, and look at their fears and look at their disabilities, and make sure that we are addressing them in our design of programs, of the devices themselves, and so on.
Okay, well, on that note, I just wanted to say thank you again for joining us, especially Carlos from the airport. And if anybody here is interested in this topic, I highly recommend you check out the BECC conference. We still have registrations available. And if you want to just join the virtual opening day, that is also available at a reduced price. Go to becconference.org and join us in just a few weeks. Thank you, Carlos. Thank you, Therese, and we'll see you there.
Thanks for inviting us.
Thanks.